Okay, this video is showing you more examples of the one-to-one property, but this time we are going to add in the natural base e. So once again, the one-to-one property is the a to the x equals a to the y. If x equals y. With the natural base e, it will be e to the x equals e to the y, then x equals y. So as long as you have the same base as e, then you can set the exponents equal to each other. So if we look at a couple examples here, the first example, you have e to the 4x plus 3 equals e to the 2x minus 6. The e's are the same, so you can set the exponents equal to each other and solve. You get 2x equals negative 9, x equals negative 9 over 2. Okay, so the next two examples, you have the e as well. So if I set the exponents equal to each other, okay, so this one now is a quadratic because it has an x squared. So a couple things to think about. If you have an x squared, then you will have two answers. Okay, another thing that you need to keep in mind is you are going to have to factor. So this is taking you back to Algebra 1 and being able to factor. So you need to set this equal to 0. Set equal to 0. So I'm going to add the 8 over. Okay, and then this is where maybe you guys remember this. You're going to draw two sets of parentheses. And you say, what adds to C, or not adds to C, what multiplies to C but adds to B. So what multiplies to 8 but adds to 6? And that would be 4, and 2. So you're going to have x and x, and then plus 4 plus 2. Maybe you guys are remembering this a little bit. And then now you have your two equations. You have x plus 4 equals 0, x plus 2 equals 0. And then you can solve x equals negative 4, x equals negative 2. You will have examples like this on your homework, so you definitely will want to look at this. So the next example, you have e to the x squared minus 24 equals e to the 10x. So I'm going to set those exponents equal. X squared minus 24 equals 10x. I'm going to get the 10x to the other side, so I can set it equal to 0. So minus 10x minus 24. And then what multiplies to negative 24 but adds to negative 10? And I'm going to think of 6 and 4, 12 and 2. So I'm going to say negative 12 and positive 2. So that's negative 24 and negative 10. That works. So x minus 12 equals 0, x plus 2 equals 0. Solve those and you get 12 and negative 2. Okay, the last two examples. These are continue on examples from yesterday. So take a look. We need to make the bases the same because they are not the same. So we're going to use 7. So this first one you don't have to change. But now you're going to say 7 to the what power gets you 1/7? And that would be -1. So now you want to say, you know what, I'm going to change this to an x. Okay, so now you can set your exponents equal to each other. X minus 5 equals -1. Add 5. X equals 4. You're hearing my dogs bark in the background. Okay, now with the last example, you have 16 and 128. So with the 16, you can use 2 as a base and 4 as a base. So you want to look and see which one will work better. 4 doesn't work, so you're going to have to use 2. So 2 to the what power will get you 16. That'd be 2 to the 4th. Then you have the 2x plus 3 left over. Then 2 to the what power gets you 128. And I think that's 2 to the 7th. And then you have that extra 3x. Don't forget about that. So now setting those exponents equal and multiplying, you get 8x plus 12 equals 21x. Subtract 8. 21 minus 8 is 13. 5 by 13. 2x equals 12 over 13. Okay, so this is just adding more examples with the 1-to-1 property.